Hello. So today we are solving a question from Leetcode, that is maximum or. So let's first understand the question. You are given an integer array nums of length n and an integer k. In an operation, you can choose an element and multiply it by 2. Okay. Return the maximum possible value of nums 0, nums 1, nums or that can be obtained after applying the operation on nums at most k times. Okay. Now that a or b denotes the bitwise or. Okay. So let's understand what this question is telling. So the question is telling about, okay, that we are given an array. Okay, so it's represented like that. Okay, 8 to 1. Okay, and you have been given a k. You can multiply it by 2. Okay, so multiplied by 2 means what? It means that in the bits representation, if you see, like, okay, if you take your 1 0 0 0 1, okay, and you multiply it by 2, so your number gets shifted by one position. So it is what it means. Okay, and you can apply this operation at most k times, okay, in any of the element, and then you have to find the answer of 8 or 2 or 1, means after applying. Okay, so it will be not be 8. It is like, okay, you're up, like, it's for a1 a2 a3, and you apply the operation maybe in a1 and a2 or a2 a3, or only in a1, so your a1 dash, so, or a2 or a3. Okay, so this is what you have to find. Okay, so now understand one thing for sure. Okay, in this question many people can get distracted about, okay, that this is the question of dynamic programming. Maybe yes, but it's not. See, you can be like, okay, so dynamic programming works like, okay, you've been given a1 a2 a3 up to an. Okay, and you apply this operation to this one, you apply this operation to this one, or you skip this, you apply one operation, two operation, three option, you then apply to this one, 3 4 2, or means if the operations are remaining, then you go further. But actually this doesn't give you right answer, because what does dynamic programming does, it gets back element and then it gives maximum, it gives the back element and it gives maximum. Okay, so there may be cases. See, what it means is that when you iterate from here to here in dynamic programming, general recursion function, it look like, okay, index plus 1 and all that states, okay, fine. But in the given question, you can pick any element, and you can, it's not that from last you get maximum then you give to it, from last you get maximum and you give to it. It's actually that. So it's not that. So in this type of question, the dynamic programming doesn't work. First you have to understand this, because I myself thought that, okay, it can be solved, but it was not giving the right answer. Now understand where to apply operation. Okay, so first understand where to apply operation. Okay, so first understand this equation. What it is telling is that 2 raised to m is always greater than 2 raised to m minus 1 up to 1. Okay, and you can see the proof. Our, like, okay, we have learned this a comma a, okay, sorry, a comma a plus ar square up to a r into n minus 1. So we know that its formula is nothing but a into r raised to n minus 1, and here you are r minus 1. We know that this is 12 standard 1. Okay, so from here it is proof that if you sum all the elements of back, it's 2 raised to m is always better. Now why this equation is important to our question, let's understand it. Okay, so let's understand it. Okay, see, here I have taken, here is k equal to 2. Okay, here is our k equal to 2. Okay, and here 812 I have represented it as in bit form. Okay, and what I did is I applied it here. Now, so what happened was that in this position it was 1. As I applied 2 here, see, I have options that I can apply 2 here, I can apply 1 here, I can apply 1 here, 1 here, I can apply 2 here. But what is the best case that I can get maximum? Okay, I can get maximum. See, the one thing should be noted is that this is our best position, this one, right? This one is our best position. Wait a minute, see, okay, so this was our 1, which was here. Why it's best position? Because if you multiply it, you get here 1. Okay. So why it is better? Okay, so let's understand it. Okay, let's understand it. See, I have taken this and I have multiplied it. So what happened was that here, as it is fifth position, my increase was of 2 raised to 5. Although my decrease was also there, which is 2 cube, it's fine. But my increase was 2 raised to 5. Okay. Here, what happened is that I took another option. I apply 1 here, and I apply 1 here. What happened is that there was increase of 2 raised to 4, and there was increase of 2 raised to 1. Now, as I prove here, see, as I prove from the equation of last equation that, okay, 2 raised to m is always greater than sum of all its previous elements from this, okay, from this. So you, whatever you do, but you increase here, you increase here, you increase here, you increase here. But what is the main thing is that this, your end, which is this part, how much left it can go, it is good for me. It is good for me that this element, so okay, so this here, my this one, how much left it can go, this is my main aim. And so I do the operation in any element and I get some, or I get some increase in after, like here I can get increase, here I can get increase. Okay, but the main thing is that even if you got increase in 2 raised to 4, here also you get the increase of 2 raised to 1, it is always very less than 2 raised to 5. So the main thing to understand from here is that try to apply this operation at one element only, so that this one can get at most left. It is very better than I am applying operations in different form, because it is useless. As you can see, it will 2 raised to 4 and it is increase of 2 raised to 1. It is useless. If I can get 2 raised to 7 and I am getting an increase of, like, let's say 2 raised to 6 plus 2 raised to 5 plus 2 raised to 1 plus 2 square plus 2 cube, but I'm still getting sum of 2 raised to 7. This is an example, so I will choose, okay, go with one, only apply operation to one element. Okay, so now see, one thing you have observed is that you can have one algorithm. Okay, so here what was our test case? So test case was like, you pick up the element which is having 1 at leftmost one and apply that operation. Okay, and then you get maximum. But there may be case, okay, you have more elements like this, 1 1 1 1. Okay, you may have, so where to apply? Okay, so applying this is very much better, or applying this is very much better. You have understood one thing, my friend, that, okay, applying this and this is very much better, because it will make us I would say 2 raised to 5, then giving me sum of like 2 raised to 3 or 4 or 2 raised to 1. It is much better. Like going the left side, it is much better than getting some of the tighter one, right? As I have shown here. Okay, so from here and here, which elements to choose? So choose everyone, iterate through all, and get maximum. Can you do it? Yes. See how. Now let's go to the understanding part, how we will be doing it. Okay, so you need, so let's say you have an array. So whenever we are with this type of questions, we have to be come in the bits. Okay, so this is our elements of like 8, this is our element of 1, and this is our element 2. Okay, so we are now at bits. So let's say we make our all elements in the bits form. Okay, and the sum. So how do we find, if, okay, there is a one way to find the OR. There is one way to find OR. It's like, okay, do this 8 1, okay, or 1 1, okay, 1 and OR 2. This is one way. Okay, can you find from the bits? Okay, so how you can find it? So let's understand it. See, in this position, wait a minute, it is getting okay. Okay, so let's say you are in this row. If the sum, if there is any one in this row, I can give my OR at this position is 1. Or if my sum of is greater than 0, okay, so here is mistake, sorry, here it will be 1, sorry. So the sum is here 1, so my OR is also 1 here. Why? See, my sum is greater than 0, then my OR is 1. Why? Because if my sum is 0 only, if there are no 1, if my sum is 0, then I say that at this bit position, 0th position, okay, at this position, position, okay, at this 0th position, there is 0. So from sum of the bits of OR, so from the sum of the bits at that position, you can get that, okay, there will be or not, means there will be 1 or not. If my sum is 0, then I can definitely say at that bit position is 0. And if my sum is greater than 0, then I would say it's 1. Okay, so how do we get of OR? We can get if in sum at that position is 0, then that bit doesn't contribute to OR, so we don't consider it. So we just do it. Okay, now as we know that all k operations should be applied at one position, so we apply and then check and get our maximum. Now, so see, my approach is now that we have array count of 49 size. See, it is just for bit. So as our element is maximum 10 is to 9, means it's around 2 raised to 31. I would say 31 minus 1. Here is 1. Okay. So, and my k operation, my k of this is, you need to understand, okay, as my k is maximum 15, so my, let's say I have maximum number, I have 32-bit number 1 1 1 1 1 1 1 up to what I can say 1. This is I would say 31. Okay, 31 bits. Okay, and you apply here operation. Okay, so this all the bits will be shifted left 15. So my last position will be what? Will be 46. 46. Right? So here is 46. So I'm just maintaining an array of 49 just for safety purposes. You can maintain it of 47 also. It will work. And long int can hold 2 raised to 63. So at your maximum, we have array count or sum, which is and some array, which is of some array of size, I would say 49. Okay, this is just, you can declare till it 63, or I would say yes, you can declare it till 63, but I have made it for 49 for it optimized purpose. Let's go with algorithm, how we'll be doing the next our part. Okay, so I have just shown you something. Okay, so this is, let's say, our test case. Our test case is 8. This is, okay, means we can count it. Okay, now some array is this. You can see 0 0 2 3 1 2, and from that we can easily find OR. If my sum is equal to 0, then and only then, okay, if my sum is equal to 0, then at that bit position is 0. So my OR of this element is, as you can say, is this one, which I got from this. Okay, now let's apply. So I know one thing for sure. Let's say here my k equal to 2, just for explanatory purpose, I taken k equal to for easiness. So I know that I have to apply operation at one position. Let's say I apply it first, it here. So k equal to, my element will now with this one, 1 0 0 0 0 0. Then I counted my sum. My OR is now this. Okay. Similarly, I do for this. What I did is, okay, sorry. So I applied for second position. My all the bits are shifted by 2. So now it is 1 1 0 1 0 0, and I got sum of this giving me this OR. Similarly, I apply for this. My sum is this. My OR is this. And I applied last number. Okay, so okay, sorry, is 0, sum is 1, and it's 1 0 1 0 0, and I get sum of this, so I get OR of this. Now for my answer, I will took my maximum OR, which is, my answer is nothing but this one, 1 1 1 1 1 1 is my answer. Now applying operations means multiplying it with 2 raised to k, that is nothing but this one left with k. So this function actually works in O of one time, actually, that's why I am using it. Okay, this is the fact. Okay, now let's go to the next part. Okay, how we will be implementing, what we will be doing. So we will be having a sum array, our a vector. Okay, vector of, I would say, count or sum. Okay, count or sum. Okay, okay, and what I would do is that, see, so let's take this example. So what I will do is that after operation, I will delete my current. See, this is my one which is contributing here. Now my sum array, I will pre-calculate it. Then what I will do, I will iterate through all the elements. So let's say I'm at first element. What I will do, I will first minus this one from my sum. Then I will apply my operation here, and then I will add all the ones. Then I will update my sum array. So here you can see here was 2, now it is 1. Here was 2, now it is 1. And as it was 0 here, now it is 1. So I will just update my sum and I will get my OR, and thus I will then update with it max. Means I will keep updating it with max. Okay. So for getting the sum array after operation, you need to delete the current count or from sum array, and then add the updated count to sum array. So here I have illustrated you. So 0 0, as here was 1, so my 2 minus 1 became 1. Okay, this is my only delete operation. My updation operation is like, okay, here position is 1, so I update this with 1, and then I get my updated OR. So I will just use a count array of 49 size, and that's it. Okay, so let's go to the code part. I don't know that are you able to understanding it or not. You can ask all the doubts in comments section. So yes, so I have declared my count here, which you can say sum array, count array. So currently I will count all the I would say all the bits, okay, at position. So I would iterate in my array nums, and when I'm in nums, I would iterate through all the bits. How many bits maximum? I would have 49 bits. Okay. So actually that there is 47 bits, but for the worst purposes, I'm taking it 49. Okay. Plus, sorry, it's with J. And okay. Next thing is that you just check it. Okay. So how do you check it? You just end it with one left J. So as you will be knowing that, okay, this number is like, okay, so let me explain this one. Okay, so here is our nums of I. Okay, so nums of I and ij. So it just give me the if it is 1 or not. So one left shift j is like, let's say, or this number is just one number, 1 0 0. So and your one left shift 2, so it's 1 2. So here this is what is one left shift 2. You AND it with you AND okay, you AND, okay. So AND will give you this one. If this is greater than 1, greater than 0, then okay, that bit position is 1 or it's 0. So if you left shift it with, let's say, one left shift 1, so at this position there will be 1, and my AND will be what? It will be 0 actually. So my AND will be 0 0 0 0 0. So for checking it, okay, at that bit position is this 1 or not, I will use this. Okay. So if nums of I and of 1, understand important thing, this does not give always 1, it gives greater than 0. Okay. So this is what you need to understand also. Don't make it mistake. And so my count of that bit, I will increase by 1. Okay. So I have initialized this. Okay. Now I would iterate through all the elements. And I will take a vector of int count1, which is equal to count. So this is just like O of 49 operation to just, so my count is remains same after always. Now I would remove the current elements, delete. So I am performing the operation of this. From you need to delete the current count from sum array. So I'm applying this to -1, wherever I will found one, I will delete it from my count or sum array. Okay, so same thing here. I will iterate through all the bits, and if you found one from count 1 of j, I will delete it. Now what I will do, I will okay, so I will update that. Okay, so let's take long some z it, that is nums of I into my operation, applied operation. And now I will add all that to my count of, so it will be z here, count 1 of j plus plus. So now so after operation I am updating my count 1 array. So now I am performing this operation, then add the updated count to some this 0 plus 1 operation. Understand, this 0 plus 1 will be now here where here at this position it is 1, it will be updated with 1, right? So I have done count 1 plus plus. And now so I have a variable, our answer, which is our maximum answer. So let's just give it 0, and at the end I will return my answer. Okay, so after that I just need to iterate through count, and from that count, or see, this count is similar to sum array. It's just it is same as count. Okay, so don't get confused with it. Okay, so count 1 or count, so count 1 is updated. Okay, and now I just need to, my answer is 0, and now my answer 1, or I would say my number after operation num is just adding that bits where there is 1. So what is that number after my, what is OR? I'm taking the OR of all the elements after applying this operation. So my so here I just need to say that, okay, if my count 1 of j equals 1, sorry, is greater than 0, then I have to consider that element. So my num plus equal to what? It is nothing but 1 left shift j. So I will just consider that element, and now I have OR of all the elements in the array. So I will update it in my answer, num. So yes, we are done with the question. So see, it was simple question actually. I will explain through. This big for loop is for pre-computation of count array, which will store all the whole whole bits, count of all the sum of all the bits at the particular position. And then we have iterate through every elements, deleted its previous one num, updated that num, and then see, okay, so this was an extra. Okay, and then I have got OR with O of 49 operation, and then I have updated my answer. So as from sum array to get OR, it's like if its sum is greater than 0, then get it 1. And as we know that how to get number from OR, so it's from this array, just to multiply it with 2 raised to 0 here, 2 raised to 1 into 1, like that stuff. Okay, so thank you. If you have any doubts, you can ask in the comments section.